What is chaining and what are the ways we can do the chaining in a large language model? Good day guys, my name is Melvin Satheesan. Today we are going to discuss about sequential chaining and parallel chaining. So let's consider this example. We have a request coming from here and an end user here. So our first thing going like a request is coming, then this is the first request. We are giving something like tell a crime story. Okay, so once the crime story is created, then we are going to request the model to do two stuff. One is tell about the different version. This is going to be different version. That means it is more supporting the person. Second is going to be accused version in the case of a crime, right? So we can run this two versions parallelly. So this is called parallel execution since these two are independent. So assume that we have for writing a story it takes 10 minutes. Then for writing the defend version and accused version, each requires this requires 15 minutes and this requires 10 minutes. So if we are executing it parallelly all together, this activity will be providing an output in another 15 minutes because this is parallelly executing, right? Now perfect. So overall this is going to be 10 minutes and this is going to be 15 minute. So we will get output here. So and let's say this is 10 minute. So if we do we have created a story. The story will be provided to defend version and accused version. In that case, 10 minutes for creating the story, 10 minutes for defend version, 15 minutes for accused version. So this together will take total 15 minutes. Okay, this will wait until this that's completed, and we will be getting an output in 10 plus 15 25 minutes. Okay, this is a independent task since it is parallel, right? We have another option, that is first we will be creating a crime story. The crime story would be giving it into different version. So the different version may go and create a document that may takes 10 minutes. Then accused will be creating a document that takes 15 minutes. So here itself it will be taking 25 minutes plus 10, total 35 minutes. So 10 minutes additionally it is going to take. This is called serial execution, and the previously the one we discussed is called parallel execution. And one more thing I would like to tell you is here we have a tell crime story. This is one large language model function. So in this function we are going to give input to different version, right? So when we are asking to tell a story here, it will be providing a story, right? That story we are passing to here. This is the next function, completely different function, right? So this function is called chaining. We are chaining the output of this function with this function, and we are chaining the output of this function with this function. So that is called chaining. And let's do a simple example in our Jupyter notebook. Okay, as you know, in our previous video we have already configured a full stack observability for this to understand how the packet is flowing and all. So the full stack observability code we copied as it is. Now we have to import our favorite large language models here. For that, from Langchain is the one we are going to use here. So first we are going to import the prompts. So let's do three promptings. First system message prompt template, then human, somewhere we will use this. Okay, next is chat prompt template. So the prompting part is fine. Next is going to be Langchain core dot output parser, because we need to define or do the modeling of our output. For that we need to do string output parser. Okay, next we have to download the chat module. So that we are going to do is Langchain Olama chat module, we are importing it. So for that, import chat Olama. Okay, next we are going to import Langchain core runnables. So in that runnables we are going to import parallel runnable. Okay, in this we need this basically in sometimes. Okay, all these modules are available. Now we have to do the base underscore URL. We are going to create a Olama instance. For that we have already Olama running in our local node 127.0.0.1 colon 11434. Okay, so our Olama is running here. Next is model equal to Llama 3.2. so we have that. Next we are going to create our instance LLM equal to chat Olama. Then here we will go to base URL equal to base URL comma model equal to model. All right, so our instance is ready. Next we are going to give a prompt. For that, let's say crime underscore story. Okay, in this we are going to give chat prompt template dot from template. We are creating a template here. From that we will be importing the things. Okay, all right, so you are a crime story generator. Write a story based on the, we are going to give context. All right, so that part is fine. Now what we will do, we want to execute it. Okay, so for that crime chain, let's say that crime chain equal to crime story pipe LLM. What we are going to once we are passing a variable here. So this context is going to be the variable. We are going to say that okay, write a story about a robbery. So it should provide us the output. So this template we are defining with a proper formatting with the context. Then once that part is completed, what we need to do, this template we have to pass it to this Olama instance, the large language model, right? So that it will process this particular string and it will provide us the output, right? Once we get the output, we want to do in a short and sweet manner, right? So for that we are using string output parser. It's a method basically. I hope this is clear. So we have a template here. That template we are passing it to a large language model instance, and the output we are further passing it to a string output parser, so that we will get a one line or a stringified output. Now let's do response equal to crime chain dot invoke. We have to invoke it, right? And while invoking, what is the expectation? We have context here, so that context we are passing it. Person Nick robbed a bank. Okay, then we are going to do a print response. All right, so let's execute this and see the outcome. And on the other hand, if we look at it, our full stack observability, let's go here and we would be able to see that okay, something is happening here. We have requested a person Nick robbed a bank. That's the context we set it up, and it is still in progress, right? So total 23 tokens involved in that transactions, and this is our full stack observability, and we are using the Langsmith. Okay, I can't provide you with a story about bank robbery. Is there anything else I can help you with? Okay. Write a story based on, write a imaginary story based on the context, so that our model should provide some uh, okay, let's see what is the outcome. Perfect. So it was a typical Monday morning, and so we have received a very nice story. Well, now this is our story. So we are the end user, and we requested the model to create a story, and the story is ready, right? It provided us a story. Now the story will have two version. One is we are thinking about thief's angle. Second is we are thinking about bank's angle. Okay, so for thief there is a an advocate. For bank there is an advocate. These two people together will go to the court and do the arguments and get the court feedback, right? So how do we do that? So let's do this way. One is we are going to do the let's say defense version equal to, we are going to do chat prompt template from template, and you are a defense advocate and you have to share the points for your client. Okay, the case briefing is I'll be providing okay case story. All right, similarly I will do one more thing. This is for accused version, and I'll be saying you are an accused advocate and you have to share the points for your client. The case briefing is so and so. Okay, so we have two part, and that is, this is our defend version and accused version. Perfect. So for both the people will be learning or will be studying the crime story, and they will provide their feedback. Let's take the feedback now. Okay, for that we are going to, let's say, the court trial equal to, first we are going to do a defense version trial. Okay, so defense version required a case story, right? So what we will do, let's do it in this way. Okay, it will be very tricky. Remember, I'm just declaring it as an object here. And what is the expectation? They need the case story, right? The case story will be here. So from where are we going to get the case story? The case story is going to be the output of this crime chain, right? So this crime chain will provide the case story. I hope you understood, right? Since we have already invoked this with the LLM and string output parser, it is going to be provided a string output. So that is the crisp and clear. This output is passing as a this is the crime chain output, and this is the body. This we are assigning to here, so that when we execute this defense version, it is going to provide this variables will be fitting into this variable, and it would be able to provide you the feedback. So I hope you are clear on this part. Let me know if you are having any doubt on it. Next, so we have provided the output here. Now we have to call this function, right? Then only we would be able to get this defense version, right? So for that, what do? We are going to do the same thing what we did here, right? Defense version. Then we will go for LLM, and then we will go for string output parser, right? So we have core trial. Unfortunately, we haven't executed these three things. So let me execute from top to bottom. So our core trial is ready, right? Now if I type core underscore trial, the function is being stuck because of this one. We were supposed to comment it out. I'm commenting it out for now. Let me restart the terminal, and I need to show you what are all the arguments it will be accepting it. So in this, it's being executed from top to bottom. All right, so if you look at the case story, it is going to take the context as an input variable, right? So we would be providing the context as an input variable. So let's do this. Response equal to court trial dot invoke, and here it will take the same context we are going to give. Okay, same context. Now what we are going to call, we are calling to the defense version. Okay, we are calling the defense version. And it's taking some time, no problem. And let me print the response too, so that you will understand that. And if we look at the full stack observability, yes, here it is printing something. It's still in progress. All right, okay. Person Nick robbed a bank, and we are yet to get the output. Let's go back here. Yes, it has provided the output, and soon it will be updated. Yes, it has provided the output. Perfect. So what has happened here? I'm going back to the diagram again for your understanding. We have here a user give a story thread, and our storyteller told a story. That story context we have provided to the defense version. Then the defending advocate provided a feedback over here, right? So that part is completed. So we provided input and we got output. That output we changed to this one. Now let's change this output to accused. How do we do that? Same stuff, same step I'm going to copy, because I want to make sure both my functions are working as expected. Rather than defense version, I'll be providing accused version, right? In that, I'll be telling that this is going to be quarter trial 01. This is going to be quarter trial 02, because different days we did it, right? We did the court procedures. So I'm going to say this to this one. Okay, perfect. And in this, what we will do is we'll just comment it out for now. As you know, the court trial 01 we already executed and it is working as expected. So we have no doubt on it, right? So let's do court trial 2 so that you will understand in a better manner. All we need to make sure that these two functions are working as expected. So this is executing in a sequential manner, right? Now we are going to do a parallel execution, right? Let's look at the full stack observability. What is happening here? Okay, so it's getting updated. We provided the feedback and it is still in progress. In the meantime, what are we going to do here? So let's take this out back, and we would be doing this, right? Now we will be getting an output. For this, we need to create two keywords. One is defend, and here we will create accused. See, these two are the keywords, and let's say that here we will be getting the output. So the output is going to be how do we call the defend version? It will be as simple as output, and output is an object. Inside the object we will have defend. Similarly, we will have output is an object, accused will be another key value pair of this output object. Okay, that is what we are going to do. So I just want to let you know before we proceed further. Okay, so in this we have successfully tested court trial 1 and court trial 2. So the judge listened the court trial what it was saying, and the accused statement as well. So these are the points. Now we are going to consolidate this two part. We are running it parallelly. How do we do that? Okay, let's open another one. So here I told you that we have a runnable parallel, right? Let's write uh, some stuff called let's say that response or output. Okay, or we will do a composite trial. We are doing a composite trial parallelly to two tasks are being performed, right? So as you know, we will be having one thing for sure. This is needed. Crime is needed. Crime chain is needed. So for that, what we are providing in this, we need two variables. Case history is needed, right? So the case history we are gonna provide. From where we are going to provide? Using crime chain. Okay. All right. We have this in place. Next, we are going to do that is going to be given by runnable parallel. So in runnable parallel, what we are going to do? So that is, first is going to be the defend and second is accused, right? So what we will do is defend equal to court trial 1 and accused equal to court trial 2. So this is going to be our output. Okay, now we don't need it anymore. Here we will be doing composite trial. So in the composite trial we are providing here. So in this crime chain, what we are going to take? We are going to take the context, right? Because this is our first story. So it requires the context input. Once the context input is there, it will automatically provide the case story, because that is what happening here. All right. So here we are going to do response. I will change it because in our previous example here I told you that we are going to capture it in the output, right? So in order to avoid confusion, I'm going to assign that output value to output. So here output, and I'm going to print output. All right. So let's execute it again and see what is happening. So in this case, if you look at it, we are giving the first function, second two functions will be getting executed parallelly. And if you look at here, let me run it again. So it throws the error stating that the input chat prompt template is missing variables context expected context received. Okay, so let's do this way. Here composite trial, right? So cloud trial, core trial 01, core trial 02, those two are being provided here. So the composite trial, let's see the output how it comes. Let's look at the versions. So the first one, case story, we are going to provide the context, and then it is going to give the chat prompt template. Defend is going to be giving the context as an input variable. Here its case story is going to be giving as input. Okay, I got the point. So since this is the first chain, and here we are already providing the case story chain, crime chain, right? And here also we are providing the output. So let's take this out and see how it goes. Okay, my apologies for the confusion created here, and let's look at it how it goes. Okay, it's gonna take some time, guys, so in the meantime I'll just pause the video for some time, or let's go back to the full stack observability. So here something is happening. If we look at here, right, so this is a runnable parallel job. So if you look at here, the first one, map key defend, and here if we look at here, we have provided person Nick robbed a bank as the context, and when we look at the case story parallel, the output, that case story that we have already provided here. So based on this, they will be providing the output, right? And similarly, the second one also gonna provide us the output. So this is what is happening. Okay. So I'll pause this for a minute, then I'll be back once the output is ready, then we'll do further detailing. Guys, the first output that we have received here is, I can't fulfill that request. I can however help you write a short story. Perfect. So we don't want that. In that case, we will do here, we'll cancel this execution. Okay, so let's cancel it. Next we are going to do you're a crime story writer, write an imaginary story based on the context, and this is just for an entertainment purpose, not for any it is there is no connection with the real life characters. Okay, I'm just gonna restart this. So we just refined the prompt. So let's look at it, what's happening now. So it should provide us some output. So guys, I'll be pausing once again because the video length will be more, so we'll be back once the output is ready. It seems it's not generating a crime story, so let's do that first. In this case, we have something called here crime story. So what I'm gonna do is crime chain is there. So let me just uncomment this and I'll execute from top to bottom. Okay, so from here we will print once again. Let's see how it goes. So I'll be pausing once again as the system is quite slow. See guys, it says that I can't fulfill this request, can I help you with something else? So in this case, rather than we mention something called a bank robbery, I'm going to mention a bank robbery. Okay, I will rerun it. Okay, so from top to bottom. So let's see how it goes. I'm pausing it once again. Guys, I tried without mentioning a person's name so that it is working as expected. Perfect. So we will adjust our output in this way. So let me delete this. We don't need it, and we don't need it as well. And I'm just gonna tell a bank robbery. Okay. Excuse me. So I'm going to execute from top to bottom. Indeed, I'll pause for a minute, or rather, let me check here. Something is in progress. Okay, a bank robbery, and do we have something? Right. So if we look at here, a bank robbery, we are ready to get the output. Well, no problem. So I'll pause for a minute and we'll be back once the output is ready. Okay. Yes guys, our output is ready here, and if you look at it, we have two components. One is the defend, and accused will be here somewhere. My apologies for this delay, as because this is going to be like a live coding. So I'll go output. So here the first component is going to be defend, right? Because I mentioned here as defend the first keyword. Let's see what defend lawyer says, and then the same thing we will go and check in the accused. Right, so first execute this defend points, and then second is going to be the accused point. If you look at here, these are the points received from this. So on the other hand, this was executed parallelly. So the output input, whatever we have provided, passed through the first chain, master chain, and from there it passed to the defense version. And this runnable parallel is the method which enabled us to execute these two functions parallelly. And this defend and accused became like a object, and that came under the hood of this output variable. So output is an object. Inside the object, defend is one key, that the value is the defend lawyers update, and accused is another key, the value is accused lawyers update. So this way we received the output. So this is what the parallel execution. So today we have learned about how do we execute serially. That means, let's go back here. Here to here it is going serial, and here to here it is coming as a input is coming here. From here we are providing the payload to two functions that executed parallelly, and then finally the output came to this segment, and we captured the output and we are using it further. So thanks for watching the session, and in the next segment we would be discussing conditional routes. Let's say that we are providing an input here based on the story. This will decide whether the defend version to be executed or accused version to be executed. So we would be putting one router here, and that router function will decide what to be executed. Since the video length is quite high, so I'm just covering that segment in our upcoming video. Thank you once again and have a great day. Bye bye.